All right, hello everyone, and welcome to ZO San Francisco. This is the fourth official ZO San Francisco meetup, and today I am delighted to give you two talks, two all original talks by faces you have probably seen before in the Scala ecosystem, including Damian Reeves, who last spoke at Functional Scala 2020, and Adam Fraser, who has spoken at many meetups and ZO symposiums over the past few months and couple of years. So today, this meetup is sponsored by our friends at Capital One. Capital One is a technology company first and a bank second. And I am very excited at the way in which they are using functional Scala to solve some very challenging business problems. So if you are a Scala developer and you are looking to write functional Scala full-time and solve some very challenging problems, then, and also you want a chance to work alongside people like Damian and Adam and other people, other folks from Zyverge, as well as names and faces you've probably seen in the Scala community, then definitely give them a call. So we're going to start with a talk from Damian Reeves, who is a distinguished engineer at Capital One. He's part of the firm's core modernization initiative around core banking systems. Damian is helping to drive the direction around the modeling of financial instruments in a safe, robust, and user-friendly way. He has over 17 years of experience in the financial sector, and he's been a part of key initiatives at other companies like Morgan Stanley and Alliance Bernstein. Damian loves functional programming and metaprogramming, and he's been a core contributor to the Morphere project, which started at Morgan Stanley as a way to apply functional domain modeling to the design of various financial systems. Morphere is now open sourced under an open source umbrella organization, and it continues to be an inspiration for other work that Damian engages in, both in his professional and personal time. He's going to be giving a talk today entitled "That's So Meta," and this talk is going to be exploring how metaprogramming enables you to power core business logic and decisions. Those of you who saw my talk on Scala 3, this is your app on Scala 3, you know that I'm a big fan of metaprogramming. I think it has the potential to tremendously simplify and eliminate a lot of the boilerplate that developers end up having to write, as well as give you the ability to check things at compile time in a compile time type-safe fashion that can cut down on the number of runtime errors and give you confidence that your code is actually going to work in production before you ship it. So I am excited to hear today what he is up to using metaprogramming to power some critical business infrastructure there at Capital One. Please, if you're signed on to our Discord, go ahead and help me welcome Damian Reeves. Damian?
All right, a little technical difficulties, but hello everyone. It's great to be here for this meetup where and I'm here to not only I'm excited to represent my group at Capital One. As John said, we are doing some really interesting Capital One, and this talk is about metaprogramming, but it's also more about our journey at Capital One on how we are using metaprogramming to enable just different things. So let me share my presentation and we can get going. All right. So as I said, name is Damian Reeves, and I am a distinguished engineer at Capital One. And I've recently joined as of June, I believe, at Capital One. And part of what the challenge that myself and the team that I'm with have taken on is to be able to allow our business domain to be modeled. And we're going to talk a little bit about that journey, the decisions we've made, and how we got there. So let's talk about today's journey a little bit. It's going to be a journey that we're going to take in 4 acts. Act one, we're going to talk about what is meta, right? What does meta really mean? In Act two, we're going to talk about at its core. We'll talk a little bit about domain modeling and the importance of the core domain. In Act three, not Dance Revolution, but instead the DSL revolution and how we are using DSLs to evolve and to really help with the problem space that we're facing in Capital One. And finally, Act four, this is the way, which is really about the decisions we've made and how we're moving forward. So let's say, what is meta? So I like definitions. Definition one, it comes from the Greek meaning transformative or beyond, right? Great definition, probably not the one we want to really adopt for this one. So let's look at definition number two. Something is meta if it is self-referential. So it follows that scheme of a thing about a thing, an X about an X, right? So if you look at what's meta, metadata, we all probably have heard this, we're familiar with this, and that is data about data, right? So it's examples, who collected the data, when the data was collected, things like that. We've already spent multiple generations embracing metadata and its benefits. When I was in college, for example, during the rise of Napster, and the MP3 revolution, and I'm dating myself, I know, and we all quickly became familiar with ID3 tags. These tags provided metadata within the encoded audio format. But now you had data about the song, like what artist recorded the song, who was the composer, and what album the song appeared on. You weren't at the mercy of the file name to give you that information. But you had all that in the metadata. This was important as students in universities saw their MP3 libraries growing by leaps and bounds, hopefully legally, with newfound access to high-speed internet and networks. So we all know metadata, meta-analysis, and systematic quantitative review of just about all the existing scientific studies on a particular research question. It's a mouthful, but what it is thus research about the research. And we see kind of like this proliferation of when you talk about meta, it's the thing about the thing, right? And enter meta programming, right? Meta programming, as you can imagine, you can say it's programs about programs, or it's code about code, or it's turtles all the way down. So in our data focused, data heavy, big data world, it makes sense for developers to embrace a world where our programs are no longer just programs, but they are themselves a series of data points, which can be used to provide additional capabilities to the programs themselves or to our development pipelines as a whole, right? So if you look at not only your code as being code that's executable, it's also data, right? It says something about what you want to accomplish. It can describe a task. And with that, we want to, we can know what data points your code accesses. And we can do various data issues. All right. So let's talk a little bit about metaprogramming. Metaprogramming, it's not a new domain, right? For in a long time, metaprogramming has been enabled in languages. You're familiar with it. C, C++. You had macros and template macros in C and C++. Lisp and Racket has been long a language development platform. OCaml allows you actually to kind of get into the compiler and to generate your own things. You can actually change the whole OCaml pipeline. Facebook, they have something. Oh gosh, of course it lost. I just lost it. But they basically embedded themselves into the compiler pipeline of OCaml. So we know those classic languages have enabled metaprogramming. A little bit more modern when we look at it, we've got C# and Roslyn and expression trees in the Microsoft camp, F# and its F# compiler, compilers of service, and its quoting capabilities. I actually have a background where I come from the .NET platform before I came over into Scala. And we use this quite a bit. We used it for things such as aspect-oriented program to enable capabilities, but then developers start to do more things where you can do additional capabilities of just transforming your code as you're compiling it. And that's what metaprogramming enables. And of course, the Scala developers, we can, I didn't want to forget Rust, I almost passed over that, but Rust has its own macros that also enables metaprogramming. But as Scala developers, we had Scala 2 macros. And now with, we had compiler plugins that was also available. And you can find on the internet where a team at Morgan Stanley, for example, used the compiler plugins to enable their risk management system, which is pretty awesome. And then we've got Scala 3 now, which enables this new phase of metaprogramming with Scala 3 inline. A lot of conceptual stuff, so here, get ready for it. This is about the only time you're going to see code in this slide. But Scala 3 is first-class metaprogramming, and the inline keyword unleashes first-class metaprogramming in Scala. It's really simple, but here's the key bits, and it's big for a firm like Capital One. It's no longer experimental, right? It's safe, right? And those 2 points make it something that you can look at building out a platform on. And I'm probably tipping my hand a little bit, but let's talk a little bit more about and switch paces a little bit and go into Act 2 at its core. Right, let's talk about your business. The core domain is the most important subdomain of your business. It is what makes your business unique and the primary area from which business value is derived, right? If you talk about this core domain, the core domain is the most valuable part of your business, right? It's the thing that is the thing, right? But is your team's investment in the core domain commensurate with its value? This is common. I've been around for a bit, and I've seen where we can spend a lot of time on the edges instead of on the core. We're worried about CI pipelines. We're worried about translating things and how we structure the database and how we connect to systems and how we move infrastructure. And every business has infrastructure concerns, but your infrastructure concerns are not what really fills in the bottom line. So maybe, or perhaps you find yourself spending the majority of your time investing in these edges, right? Let's talk a little bit more about the core. So whether you embrace the onion architecture, right, with all the stuff that these diagrams have, or maybe you're a clean architecture person, right? You might be into the clean architecture, or maybe hexagonal or ports and adapters. What you will find is that all of these, it's really put and highlight. It says, if the bulk of your meaningful development time is not spent, is spent on the fringes and on the edges of your application, then you're missing opportunities to improve and invest in the part of your system that likely drives revenue or cuts cost, right? That's what the core is. That is what makes money. That is what differentiates businesses, right? And if you're spending all your time on the edges, this is time, money, cycles that you can spend really revolutionizing your core. So for the team working on core banking platform, like, at Capital One, we realize that the value we provide is to allow the core business to rapidly provide new products and services to our customers, right? That means new rewards programs. That means reacting to customer status changes. That means being able to adopt and comply with regulations. That means to be a platform for innovation and new initiatives. So let's see. And of course, we want to change banking for the good. That's kind of the mission statement of Capital One, changing banking for the good. Right. We have been, we've been tasked with as a team to design this platform that describes and enforces the terms of the agreements between our clients and Capital One. And company mission statements aside, when you have to provide the platform that needs to apply rules which define the terms of agreements, contracts, if you will, between clients and the bank, in terms which may have nuance changes, which may have based on customer status, their location, their region, special programs, you realize that you can't hard code and hardwire all these decision points, right? So it leaves you with some choices to make and some decisions that you have to really think about. So here we are. The DSL, not Dance Dance Revolution, but the DSL revolution. And I am sorry, my screen is not updating. I want to make sure you guys still seeing updates on my slides. All right, awesome. So let's talk about this now. So we've settled here at Capital One on using a DSL to represent our core banking logic, right? If you know what a bank like Capital One might does, we have credit cards, we have personal loans for auto loans, and all of these have rules and terms. You know what contracts are, right? It is, if you have a credit card, the rewards program that says that when you shop at a certain place, amen, that you are able to, that when you shop at a certain place that you're able to get those rewards at a certain rate, right? All of those rules are hard coded into the platform. So let's talk about this word DSL for a little, right? Domain, number one, right? So we just talked about that core domain. It is about the main thing, right? Being, what is your business? All right, one moment. I don't think my slides are updating, which is what I was afraid of. All right. Hopefully back in business now. All right, sorry about that. All right. So we've settled on using the DSL to represent our core banking logic. And what does that mean for us? I was talking about domain, right? So for domain, we've got domain-driven design, and we talked about things, that domain, that core domain being the center and the most important thing, right? And of course, if you look at DSL, that acronym, you see specific in there, right? So you want to be able to speak to a language and to circumstances that are specific to your domain, and then language. What this talks about is an opportunity point to be able to describe your problem space programmatically in a language that's very specific to the domain. So we chose a DSL. Why a DSL, one might ask? It allows us to have a constrained and purpose-built language for describing our problem space. We decide what representation works best for us, right? So we're not at the mercy of someone else. We get to decide what properly models our domain. And we decide what sorts of expressions are valid, okay? What kind of DSLs do we want? Usually when you look at DSLs, you've got external DSLs, right? This is custom language parsed independently of the language it is implemented in. The examples include SQL and GraphQL, right? And many others. But you can also have an internal DSL. This is similar to external DSLs, except they are bound to the language in which they are implemented. Examples include Akka, Play, Apache Spark, and ZOSQL, for example. These are all examples of internal DSLs. So how do we represent the DSL? We had a decision point to make at Capital One, and we really took some time analyzing and looking at the trade-offs between these different ways of representing our DSL, right? And we can roll a parser or a compiler, and you know we've done that, and we've looked at what are the costs there. I used Zio. Many of you might not know, but with through Zyverge, we've been able to use the ZO parser, which is really nice parser library that allows you to do like this combinatorial parsing like you're used to in many other libraries, but it also has a pretty printer built in, and you're able to do it all in one stage. So we looked at that. It's already providing you more than you normally get, but we found that rolling our own parser and compiler probably was going to be more of a heavy investment than we wanted to do at this time. Though I will say, when you're evaluating this thing about your DSL, having this external DSL is probably the most powerful thing you can do, right? You have the epitome of control. You're not at the mercy of the language. But at this point, we decided not to go with this, because in addition to this, you also have to roll tools, right? Visual Studio Code, IntelliJ, all these IDEs, in order to get support, while there's standards now, such as the language server protocol or build server protocol, all those things do not come for free. So once again, if we want to focus on our core domain, those become ancillary concerns that we don't want to invest in at this time. Now we can go fully embedded, right? You can, and ZO is a good example of the power you can get with a fully embedded kind of DSL. Even ZO SQL, which has been very well thought out, it shows that there is a future and there is a pathway with embedded DSLs. You have to be very disciplined when you do go with the embedded DSL, because you have to think about the domain. You have to really give a lot of thought and insight into that. If we go on, we now have this new tool called Scala 3 macros. And Scala 3 macros, it allows us to go to this other level where we can kind of describe things in ways that we weren't able to describe before. And we know we have full compile time safety. Even Scala 2 macros, while you were able to do that, there were some areas where there were dragons. And once again, for a large bank, I don't think you really want to go into experimental macro land. But Scala 3 macros offer some really great potential. And then there's this hybrid approach that one could take. And as much as Frankenstein or hybrid might sound kind of derogatory, we chose a pass. And this is the way that we chose, right? It's the path we chose. And this is kind of the grand end of all this that I really want to come to, is that we decided to use language design concepts and a language pipeline to describe our DSL, this core language, this core structure, this core domain that's about how all of you get rewards, about how your loans are structured, that captures all this stuff. And we wanted to give ourselves the epitome of flexibility. And a language pipeline, for anyone who knows, you've got this thing called a front end, and your front end is usually this internal or external DSL. We've got this intermediate representation, which kind of models everything in this domain. And then we have a backend, which can be interpreter, our transpile, our tooling. And really what happens is that now your code turns into data about data. It's data about your code. And we use this to know, for example, what fields and dictionaries are being accessed in rules. And we are able to have different departments who might all think of an account being something else. This is probably setting off bells for people who know domain-driven design, right? But we can map those, and we do these all through Scala 3 macros, which will enable us to have compile time checks, but we have also like an embedded DSL behind this. And by doing this kind of Frankenstein, if you will, this hybrid approach, Frankenstein is somewhat derogatory, we've been able to empower our developers. And we're on the path. The project is not done, but I want you to know that with the changes in Scala 3 and meta programming, that we can see a great future for meta programming on the JVM and on the Scala platform. And that's where we are kind of in our journey. I hope you liked going through these other metaverses or universes, all kind of a little inspired by Rick and Morty as well. So thank you. Sorry about the technical difficulties. That's it.
Thank you, Damian. Thank you so much, Damian. Let me go ahead and pause and see if